Humanity as a whole is curious about a lot of things. It's only natural that eventually we would question our beginning, or go even further. Not just how humanity began, but the Earth, the sun, stars, space, and even time. In this video, we'll explain how it happened and how we know that it did. At the very beginning of the universe, everything was unimaginably small, hot, and dense. This period is called the Planck epoch, and at this stage, all four fundamental forces, gravity, electromagnetism, strong and weak nuclear forces, were hypothesized to be unified into one superforce. Space and time as we know and experience them may or may not have even existed in the conventional sense. All the science, physics, mathematics, and the like fail to describe the universe at this stage, and at this point in its life, it remains one of the biggest mysteries in cosmology. In the grand unification epoch, the only thing to note is gravity's separation from the four fundamental forces, and the universe expanded and cooled slightly from the Planck temperature to 10 to the 28 Kelvin. So most of the sources I saw say that the strong nuclear force separated from the rest at around time 10 to the negative 36, which is on the interval between epochs or just in the gravitational unification epoch, depending on how many epochs the source uses, so I just gave it its own thing here. After gravity separation, the universe enters the inflationary epoch, where the universe increases in size by a factor of at least 10 to the 26 to 10 to the 30. Temperature also drops from 10 to the 28 Kelvin to 10 to the 24, which for some scale, it's about the equivalent of the universe expanding from subatomic to larger than the current observable universe, which is still expanding. So yeah, pretty big. After inflation ends, the universe continues cooling. Some things to know is that light still can't travel freely yet. It's a temperature of about 10 to the 15 Kelvin and is filled with high energy particles and radiation like quarks, electrons, neutrinos that all sort of exist together in a hot plasma. Things get more structured in the quark epoch. Quarks existed freely in a hot plasma with gluons, which, as the name suggests, binds the quarks together. However, the main thing that's happening in this epoch is matter and antimatter were constantly being created and destroyed, and in this creation and destruction, something crucial happens. A tiny balance which favors matter over antimatter emerges, which is why we have the universe that's made of matter today. Next is the Hadron epoch, which lasts from 10 to the negative 6 seconds to 1 second. And the temperature drops from 10 to the 12 to 10 to the 10 as the universe continues to expand and cool. However, now quarks begin to combine into protons and neutrons, and most antimatter is annihilated with matter. In the Lepton epoch, electrons, positrons, neutrons, and photons dominate the cosmos, and neutrons begin freely streaming through space. From time 3 to 20 minutes, nucleosynthesis begins, which, as the name suggests, the first atomic nuclei are formed. Protons and neutrons form hydrogen, helium, and lithium in order of abundance. Specifically, just atomic nuclei, as the universe was still too hot for electrons to attach to a nucleus and form a proper atom. Finally, after 380,000 years, the universe begins to appear as we know it today, literally. The first light speeds out across the universe, and electrons have finally slowed down enough to combine with nuclei and form atoms. Temperature is around 3000 Kelvin, and the universe spans 90 million light years. Although there is light in the universe, there were still no stars, hence the name Dark Ages. Hydrogen and helium filled the majority of space. Wait, but didn't I just say something about first light? How come I'm following it up with Dark Ages? Well, the light that came from recombination at the moment of release glowed with black-body radiation, about an orange-red in the visible spectrum, as well as emitting a substantial amount of infrared rays. Onward after 100 million years, gravity slowly pulls matter together and the first stars ignite. Hydrogen will burn into progressively heavier elements, galaxies begin to take their shape, and due to gravity, over billions of years, the heavens above begin to match the night sky we see today. Although the name says theory, the Big Bang is supported by multiple pieces of evidence. First, cosmic microwave background radiation. Accidentally discovered in 1965, scientists were attempting to map the Milky Way using radio waves but were plagued by low-level interference, a noise that, no matter the time or direction, stubbornly persisted. After connecting with another group which already theorized an afterglow of the universe's creation, they put together that the disturbance was the first light of the universe redshifted in microwave radiation. Cosmological redshifts were first discovered by Vesto Slipher, who was the first scientist to note that the majority of the nebulae were moving away from the Earth. Cosmological redshifts were further established in 1929 by Edwin Hubble, who was able to measure the distance of the distant galaxies. He observed that the further the galaxy was from the Earth, the more the light was shifted towards the red end of the spectrum. The red shifts provided the first evidence of the Big Bang Theory. The shifts showed that the galaxies were not just moving in the universe, but were actually expanding in all directions.